Good evening, all of you. Today we are going to see about basic RTL NOR gate. RTL means resistor, transistor, logic. That means we are realizing a NOR gate using resistor and transistor. So here we have three transistors and A, B, C are the inputs. And then we have resistor, 640 ohms, 450 ohms connected to the base for all the three transistors. So this is a NOR gate, but we have to see whether it is going to function as a NOR gate or not. First, the supply voltage is 3.6 volt, and here you can give the same 3.6 or approximately 4 volts here, or even 5 volts. So initially what we are assuming is A, B and C is 0. That means this is connected to ground. So C is connected to ground, B is connected to ground and A is connected to ground. That means the input at this point is 0 volt, here is 0, here is 0. So all the three transistors, say I am calling this as Q1, Q2 and Q3. All the three transistors will not conduct. That means all the three transistors are in cutoff. We know that when the transistors are in cutoff, it can be treated as an open circuit. That means you can imagine as if the component is not here. Okay, this is not here, this is not here, this is not here. You can treat it as an open circuit. Now VCE will be VCC because you know the load line already. So x-axis is VCE and y-axis is IC. At this point it is cut off where VCE equal to VCC. So between this point and this point, the voltage is, here it is 3.6, so you will be getting 3.6. So with respect to ground, if you measure here, it will be 3.6. So 3.6, I can say if you put somewhere around 1.45 volts or 1.5 volts as the threshold, anything above that can be treated as a logic 1. So here you will be getting approximately 3.6 volts between ground and this point, output Y. Therefore, here you will be getting output as 3.6, or I can say as logic 1. Okay, this is for the case 1. Next for case 2. Case 2, what happens is, case 2 is AB is grounded. Grounded means 0. This is also 0. AB is 0, but C is 1. 1 means I am connecting to, say, plus 5 volts. Here I am giving 5 volts. Logic 1. So 5 volts is logic 1. So now Q3 goes into conduction because it is forward bias NPN transistor. So this will goes into conduction. If I say conduction, you can treat, these two are open already. Because grounded, these two transistors will not conduct. So this will be treated as open, whereas Q3 will be treated as a short circuit. So between collector and emitter, you can assume that to be a short circuit. So ideally, it has to be 0 volt. But practically, if you see, VCE at this point, at saturation point, it is roughly 0.3. So here, even though it is short circuited, you can see 0.3 volts. So this 0.3 volts is less than the threshold of 1.5 volts. Therefore, it can be treated as 0. So for ideal case, this point is treated as 0. Okay. Next, 0, 1, 0. That is, this transistor goes into conduction now. Here we are giving 5 volts, that is logic 1. C is grounded. Here we have the transistor. So this input is grounded 0. This is also grounded. So what happens in this case? Transistor C and transistor A, that is Q1 and Q3, both the inputs is 0. Therefore, this will go into cutoff. Cutoff means this can be treated as an open circuit. Okay. So this can be treated as an open circuit. Whereas, since you are giving a positive supply plus 5 volts to the base, there will be a base current and therefore the transistor goes into conduction. So if the transistor goes into conduction, you can assume this should be a short. So this 0, this point everywhere it is 0, and the same thing will appear here also. So the output is 0 volts. For the next case, this is 0, whereas B and C goes into conduction. That is, this is short. Here you will be giving 5 volts. This is also short. That means you will be seeing only 0. In 1, 0, 0, you are giving 5 volts for this. 5 volts. So this transistor goes into conduction. Whereas for the next one, for the next transistor, this point is grounded, that is 0 volts. So this will not goes into conduction. Therefore, it can be treated as an open circuit. Here also 0. So this is also open circuit. Open circuit. The transistor is not on. So this point is grounded. But this transistor goes into conduction. Therefore, this can be viewed as this collector to emitter as a short circuit. So therefore, this 0 will appear here. So this is also 0. Okay. Now, A and B, A and C, or we are giving 1 as the input. That means 5 volts, 5 volts. So short circuit. So here also output is 0. Here also output is 0. Last case, all the 3 transistors are excited with plus 5 volts. That means all the three transistors are behaves as a short circuit, because here you are giving 5 volts. 5 volts means the transistor goes into conduction. Therefore, you can view as if there is a short between collector and emitter. But practically I told you, collector to emitter voltage will be what? 0.3 volts. That you should not forget. So, this circuit gives an output of NOR gate, because 0, 0, 0 for OR gate it is 0, but for NOR gate you have to invert it, so you will be getting 1. 0, 0, 1, output of OR gate is 1, but when you invert it is 0. So for all the cases 1, 1, 1, output of OR gate is 1, whereas NOR gate it is 0. So this circuit will work as a NOR gate. Why we call it as a RTL NOR gate? Because we are realizing the NOR function with the help of resistance and transistor, and we have designed a digital logic circuit to realize a NOR gate. Hope you have understood this topic on RTL NOR gate. Thanks for watching this video. Nandri.